Hello, hello, folks. Got a lot of early birds in here today. We're going to get started in about 2 minutes. Hi, Simon. Hey, Sydney Road, Rascal. Hey, James Pro Dev. Hey, Chris. Hey, Rav Robert. Hey, Naste. Hey, Tracy. Profile is an AI generated smurf on the block listening. All right, we're going to get started in about 1 minute. Stick with us. Hey, Fat Cat. Hey, Jasmine. Hey, Kenrick, as soon as I turn my camera on, I will redeem that hydrate for you. Kenrick coming in hot with the redemptions. Okay, well, as soon as the camera turns on, we'll do a hydrate and a posture check. Hey, Jack Tree. And it just started pouring down rain here, so hopefully the power stays on. We shall see. All right. It is time to get started. Hello, everybody. I hope everybody's having a good day. And Kenrick redeemed a hydrate. So here's the hydrate. And oh, Tracy DK, thank you so much for the sub. Wow. Thank you. I really appreciate it. Thank you, Tracy. And we got a posture check. All right. There we go. Shoulders back. And a stretch. Okay. Starting out with good posture. And limber. All right, that's a good way to get started. Hey, welcome, bangers. Welcome to the stream. Thank you for the follows, folks. I'm glad your notifications are working there, Kasava. That's awesome. Yeah, I hope everybody's having a good Wednesday, and I hope you enjoyed the stand up if you attended. Um, and I think Remo is going to work pretty well for that, actually. It seems like it's hopefully going to be a good platform for our 100 Dev stand ups. You thought it was a foster check? There is a channel point reward for kittens, and so if so, intelligence, the last on our last stream or the one before, intelligence redeemed a foster kitten cam. So if they are here today, if intelligence is on the stream today, we will do that foster kitten cam. um if not, that's okay. Well, I haven't forgotten about it, so. Hey, Abidemi. Hey, Zena. Hey, Mavi. All right. Wow. We got a full house today. That's awesome. That's awesome. Good to see everybody. Again, I hope everybody's having a good day. And yeah, so what we're going to do tonight is just a very gentle introduction to some algorithms, basic algorithms. We're not going to go too crazy with anything tonight. That's not the point. The point is to just get an introduction, because Leon is going to talk pretty heavily about data structures and algorithms starting on Thursday. And so he assigned us this course to at least get started on before Thursday's class. So that's what we're going to do tonight. Um, hey, Sunny Bro. Hey, Junior May. Welcome to the stream. All right. So if you're wondering, wait, what the heck is this? There was an assignment, and that is in the follow along materials channel on the Discord, which everyone should be familiar with. So if we go to the Discord, you'll see that part of the assignment for this week was to complete the Scotch IO Ultimate Algorithms course, and there's a link to it here. So if you didn't know that already, go ahead and open up this link and take a look at the course. Oh, Tucker, glad to get started because I'm missing tomorrow's class for a recruiting event. Oh, that's awesome. Yeah. I'm glad you get the opportunity to go to that. Um, Egan, if you want a link to the Discord, type exclamation point Leon, exclamation point Leon in chat, and that will give you a link to the Discord. Okay, so you can go ahead and go to the course here. And when you do, that will take you to the course, but you'll notice that it's actually on the archive.org. So if you don't know what that is, the Wayback Machine, it's a way of storing older websites that may not exist anymore. So it's a way for us to look back in time and see things that happened in the past on the internet. Because they say that the internet never forgets, but uh, there's a lot of the times things can be erased. If a website is bought out and the server goes down, um, or somebody wipes the data, then yeah, you can't see that website anymore. And so in this case, this course was bought out by I forget who. I looked and I don't remember anymore. But this course was bought out, and so it technically no longer exists. But the Wayback Machine remembers. And so while the Wayback Machine is a wonderful tool, there are some things about it that can't quite fully mimic a functioning website. There's be certain assets that are missing. There'll be certain links that are broken, and so I'm going to do my best tonight to bridge those gaps and put band-aids on those issues for you. So we'll get to those things when we get to them. But for now, let's go ahead and get started with the course. Oh, I got to turn my closed captions on. 1 second. 1 second, please. Closed captions are very important. So let me do that. All right, so closed captions should be running now. If you want or need closed captions, you should be able to turn them on by clicking the icon at the right side of your Twitch window. Awesome. Yeah, I can provide a direct link to the course as well. If you're not on the Discord, that's fine. Here's a direct link to the course, and you'll notice it is a web archive link. Oh, we got a couple other folks linking it as well. Thank you all. Is this course taught by Wally? No, that would be adorable, but no. Yeah, and if you missed the 100 Devs stand up this evening, it is on. Make sure that you're keeping an eye on the Follow Along Materials channel and on the Hunttober announcements channel. And the stand ups are now on Remo. So just pay attention to that. There's a Hunttober announcements channel in the Discord, so make sure you're following that if you want to attend the stand ups. How long do I plan on going tonight? I can never answer that question. However, I can tell you we won't go any longer than 3 hours. So we'll try to wrap it up by 10 p.m. Eastern. So I can give you a hard limit on the end. So we're probably not going to get through the whole course tonight. The goal is to get you started and get you the tools that you need so that hopefully you can get some momentum and finish the course yourself. Mavi, what we're going to do is we are going to use VS Code tonight to run some tests, to run some test cases in VS Code using Jest. And so, yeah, if you want to follow along and run those test cases, you'll need VS Code. What we are going to do is to get a quicker start, we're actually going to clone a repo. It's not like you're going to be starting from scratch. Yeah, we're going to be using Jest. Yeah. Is this course free? Well, through the magic of the Wayback Machine, yes, it is free. You don't got to pay for anything here. And also, too, just one last disclaimer: we got a ton of people in chat tonight, which I love. A ton of viewers tonight. There may be some of you out there that you are um, absolute data structures and algorithms masters. You know everything about data structures and algorithms. Keep in mind that we are beginners here. We are just getting the basics. We aren't about diving into the details or, the nitty gritties of data structures and algorithms tonight. We are just getting an introduction, learning what they are, and learning a few basic data structures and algorithms. Also, we're not going to debate what the best tool is or anything like that. We're going to use the tools that are mentioned in the course. We're going to make one substitution, but we're going to use the tools that are mentioned in the course, and we're just getting a taste tonight. So, just a disclaimer, I know there's tons of tools out there and there's tons of experts out there, but let's keep it in perspective. Let's keep it basic. Let's keep it chill. And let's just learn the basics of data structures and algorithms. Cool? Cool. All right. No, it's not code weenie time. If you want to be a code weenie, you got to go elsewhere. I'm sorry. All right, we will learn what, and those tools that I mentioned, like Jest, we'll learn what those are. Don't worry. We'll get to that. Let's just take things in order. And yeah, we will absolutely get to what Jest is and what benchmarks are and that kind of thing. I made it and the stream isn't even over. Yeah, good job, Fjord. Okay, let's get started. So if I zoom out here a little bit, we can see that if you open the course, you can see that there's kind of a guide off to the left. And so we're just going to go in order. We're not going to take anything out of order. We're just going to go in order and see, how far we get tonight. But we're going to make sure we take our time and, just again, chill stream. All right. And I promise we'll talk about how to use all these tools and everything. Don't panic yet. We're gonna do if you're new to my stream, we do everything together. We always do everything together. So we're gonna walk through it together. Don't worry. All right. So basically, the first section here is just an introduction. There's a couple things I want to touch on though. And so basically the purpose of this course is to basically make us aware of some of the problems that we can encounter when we're developing apps at scale. So as an app gets very large, we might have to start thinking about how much time it takes to accomplish certain things, how much space the data takes up. If we have an array of 1,000 objects, then it might take some time to get through, and we might have to be cognizant of what tools we're using to get through that data. And so it says, how efficiently things are done is mostly ignored. We write various algorithms, mostly in the form of functions, designed to cleverly manipulate data and provide the required outputs as a means to carry out various kinds of computation. Again, we tend to not worry about how efficiently this is done. And so far we haven't, right? We've been building apps and we've just been using basically whatever works, right? If we can find a method to get something done, we'll use that and we'll write some bad code and we'll just slam it out and, shove it out the door. However, as we start getting more complex and larger applications, we might need to start thinking about, okay, but wait, what is truly the best one to use? Brute forcing it. Yeah. And most of the time, there's nothing wrong with that, right? Did you make something? Does it work? Then you're good. But in interviews and as we get into more complex projects, this might be something that we need to consider. And so it says, what is the result of that? Applications are shipped into production with quirky data structures that can't scale. So by scale, we mean they can't grow larger with time. So data structures that can't scale, accompanied by algorithms that consume an insane amount of resources, both system and time. This eventually tends to affect the integrity of applications as well as destroy the overall user experience. So, have you ever used, say, like a web app where you maybe go to run a search or go to select an option and it just takes forever? And if it takes long enough, you might actually end up clicking away, right? You might end up being like, nah, I'm not going to wait for this to finish. I'm going to go somewhere else to get what I want. I think I saw that recently when there was that $3 movie ticket website that they made on movie day. And I remember searching, trying to find a theater near me. And it took like 5 minutes to complete the search just because it was, overwhelmed and inefficient with the way it was doing it. I failed many code wars because of timing out. Yeah, yeah, timing out. That's another problem, right? Exactly. Hey, MD Res. Yeah, and that's a great question. So, what is brute forcing? Yeah. So, brute forcing generally just means not really caring about efficiency, just trying every option until you get the right one. Not using any sort of special logic to narrow down the potential answers. Really, just trying every single option until you hit on the right one. So yeah, generally what we mean by brute forcing. Overwhelmed and inefficient should be my slogan. Okay, so that's kind of how at scale things might go wrong if you're, truly inefficient. Um, as always, concerns in the life of a software engineer continue to shift progressively towards certain core concepts and their corresponding benefits and away from simply making software that works. One of the core concepts is performance. So, is there a best way to structure the data? Will this scale? So, again, can I take it from my little localhost test project to a project with potentially thousands, hundreds or thousands of users? What happens when there's an insane flow of data? Which, say, you suddenly make an app and it goes viral. What will happen? Do you know? And how do I optimize these computations for better performance? Okay, so why this course? We're not gonna, we're already doing the course. We don't need convincing. But so again, you might get asked about this sort of things in a job interview. So I think that's going to be Leon's primary focus here on Thursday is how can we talk data structures and algorithms in a job interview. And software engineering trends show that performance is gold. So more and more people are online and connected and using apps, and so we need to build functional apps at scale. Speed, ability to run with minimal resources. Humans are becoming increasingly impatient. I think we can all agree about that, right? We are very impatient. We want the results right now. We want things to come back quickly. We want the app to load that next page immediately without us having to wait, which is why I'm paying for a gigabit internet connection. And more talk and less code. So that's the benefit of this course is there's lots of examples. Yeah. Brute force. Sorry, TikTok has made it even worse for me. Yeah, TikTok is definitely immediate gratification. Yeah, and going back to the brute force thing, leak codes commonly don't always work with the brute force solution. Yeah, they're going to make you be efficient. They're going to force you to be efficient rather than just guessing until you get it. Exactly. It's my data and I want it now, right? 30-second attention span. I think even less than that now. Um, okay, so the structure of this course is we're going to gain a basic understanding of algorithms and data structures, considering associated terms and the practicality of such knowledge. And then we'll implement a few algorithms and data structures, and we'll examine various possible implementations, determine the most optimal. So essentially, what we're going to do here is we're going to look at a bunch of different ways to potentially solve the problem, some of which you might have already seen, some of which might be a different way of thinking about it. And then we're going to determine the most optimal. So, optimal meaning, in this case, just meaning best. What is the best solution? And then identify some real world usages. Now, this I really appreciate. So, sometimes when we're talking about code wars, we can kind of get ourselves wrapped up into, you know, this is just a puzzle, right? It doesn't have any sort of real world application. It's just a theoretical puzzle that exists in a bubble. But we're also going to learn some real world usages of some of these applications that might crop up in a job or in the real world. Okay, so let's go ahead and get started. All right, so just this first section is really just an introduction to some of the terminology that we're going to see, which I think should be pretty useful for us. Um, and basically, he just starts out by making an analogy to a library containing a wide variety of books on various subjects. Um, so we can organize those books into departments, catalogs, shelves, or other types of collections that just show a particular relationship. Um, and so those some of those relationships could include genre, author, publisher, alphabetical order, etc. But the aim in a library is to group related content together and show order and hierarchy so that items may be located quickly, books ordered neatly and optimally, and collections browsed efficiently. So when we organize books in a library, we are saving time because it takes less time to find the books, and books are organized in a logical way in to take up the least possible amount of space. And then we can also browse our collections efficiently this way. So now we're going to take a look at the relationship between data structures and algorithms, why they're essential, and how they're like a library. Hey, Renzi. Okay, so let's start with some terminology. What is a data structure? So, a data structure actually isn't that complicated. We've been using data structures this whole time. We just didn't know what to call them. So, a data structure is just an organized way of storing data for use by computer processes. It's a pattern of collecting and organizing data for performing various options correctly and efficiently. Okay, so just like books in a library are ordered in certain patterns, um, computer programs are organized in meaningful ways. They're designed to receive, process, organize, and output data in meaningful and efficient ways. Okay, so we already know a ton of common data structures, such as variables, conditionals, iterators, functions, scope, arrays, and objects. And it says you may already be familiar with all the above terms, but we are. We know what all of these are, right? It's nothing new. Yeah, and arrays, absolutely. You're right, Don Spear. Arrays are data structures. Yes. And it just says imagine you're writing a program where you had to store some details about a person. Intuitively, what may come to mind is very likely an array or an object. And so they give us an example here. We should already know what arrays and objects are, but in case you need a refresher, an array is basically kind of like a list of information. And within that list, we can also have kind of sub lists, right? So we can have what's called nested arrays, where in this case we have one of the array. So each of these individual items in the array are singular, but then here at the end, the last item is actually another array nested within the parent array, right? We know that's something we can do. It may not be, something we do all the time, but that's still a valid structure. It's an array within an array. And the second structure here that they give us is an object, right? And also, we should know what objects are, but in case we don't, um, an object is really just another way of storing data. But one of the advantages of objects is that we can have these, what we call key value pairs, right? The thing on the left is our key, and that's the identifier for the value that's being stored here. So, what is Philip? Well, it's a first name. What is Obosi? Well, it's a last name. And so it's an identifier for the value that's being stored in this object. And we can also mix data structures together, right? So in this object, the last value here is actually an array in itself. So we have, again, we have a structure within a structure. And so the advantage of an object here is it lets us give some more specificity to the values that are being stored, right? And so let's learn a little bit more about data structures here. So, like, before I go on, any questions about, now again, I know we're probably mostly aware of what arrays and objects are, but any questions on this before we go on? Yeah, exactly, Tucker Tech. We've got a string, a number, and array all within this singular object, right? Yeah. And so we know that we can reference this just it somewhere else, like in a function or somewhere else, as a singular object, right? We can just reference user, and everything about that user, all this information will be contained within that user variable. Yeah. Okay. So it says in the code snippet above, we make use of various things that ensure that data is meaningfully handled within an application. So what are we doing here? Well, we're using variables, and we're declaring those variables using let and const. Um, and they are used to declare variables for use within the block of code where they exist. So we use let in line 2 to scope that variable to a certain block while keeping it mutable. Okay, pop quiz, what does mutable mean? We learned about mutable when we were learning about React, right? But that's a vocab word. So what does mutable mean? Yeah, exactly. Mutable means it can be changed. If we didn't want that variable to change, if we didn't want people to be able to edit that variable once it's been created, what would we use instead? Yes, what keyword? Sorry, I should have been clear. What keyword would we use instead if we wanted that variable to change? Yes, we would use const. Exactly. We would use const to make it immutable. Yes, absolutely. Let is mutable. Const would make it immutable. So if you don't know that word, put it in your Anki. It's a good word to know. Mutable, the difference between mutable and immutable. Immutable. Yeah. All right. So when we declare that variable, this at a very basic level provides context as to how this block of code should be handled. Naming the variable user also adds meaning and context to the data, as it tells us that this information is about a specific user. Yeah. So just by declaring this variable in this way, by saying let user, we're already providing valuable information, right? We're saying this variable can be potentially be changed, and naming of the variable itself is going to provide information about what could be contained within it. All right. So arrays, again, probably already know what they are, but it never hurts to review them in a more high level way. Okay, so arrays. A pretty technical definition of arrays would probably be that they are linear collections of elements that are accessed via indices, which are usually integers used to compute offsets. That's a lot of words. All right. I love the next sentence. It says, now, I do not consider myself very dumb, but this really doesn't sound simple to me. I agree. All right, so let's review it again in simpler terms. It's disrespectful. Yes, exactly. Sorry, I'm just catching up with chat there. Yes. All right. In simpler terms, an array is a container object. It's just, remember, okay, it's a toaster, right? It's a bucket. I don't know what you want to call it. It's a bucket. It's a shelf. Just a container object that is used to hold a list of items, usually of the same type. Looking at the snippet above, we declare a variable user and assign a list of information about the user to it in the form of an array. So it contains, just like a book from our library, um, will contain a list of pages numbered in ascending order for easy navigation. And so we know already that we can reference specific array items by their index, right? And that index starts at 0. So this is 0, 1, 2, 3, 4, blah, blah, blah. All right, it just reminds us that arrays start at 0, which we know, but I sometimes forget. All right, so what is an object? Objects store a collection of related data or functionality in the form of key value pairs. They're designed to hold more complex entities, usually of varying types. Here we assign an object with information about the user to the variable user, and we already kind of looked at this one, right? It contains various types, including strings, numbers, and arrays, right? And a striking similarity exists again, as on the engineering shelf in the library, we find lots of publications identified by their titles, which is the key here. So, should we use arrays or objects? So, data structures ought to hold and manipulate data that in a meaningful way that keeps the relationship between them. Oh, Purple Elf, thank you so much for the raid. Wow. Hey, welcome, Purple Elf. Welcome, Raiders. Good to have you here. Thanks for stopping in. Hey, Purple Elf. So, tonight, again, welcome, Raiders. Good to have you. Tonight, we are doing an introduction to data structures and algorithms, and we're going to do some basic test case writing with Jest and some benchmarking. So, not getting too crazy tonight. Just a basic introduction to data structures and algorithms. So, feel free to stick around if you'd like to learn about that. All right. I think my chat just bugged out, so I apologize. I won't. I'm waiting for it to connect again. Hopefully, it will. Okay. So let's see what we're talking about. We were talking about should it be an array or an object? So data structures should hold and manipulate data in a meaningful way that keeps the relationship between them. So if we dump all of our user information into just an array, we'll find that we kind of lose a lot of, we lose some information about what these values mean, right? Like, is this the person's first name? Is it their last name? What is it? We don't know. What does this 200 mean? Who knows? And so in that case, we should probably use an object, right? Because the array implementation doesn't provide enough insight into the relationship between the various chunks of data and therefore isn't very meaningful. The object implementation shows the relationship with the use of hierarchy and key value pairs, right? With one glance, we can tell what each piece of information means and how they are connected. Okay, my chat isn't working, so I'm just going to pull up the web version here real quick. Bear with me and see if I can see chat there instead, because I don't want to miss out on what y'all are saying. Oh, Twitch, so reliable. One second. Okay, chat might be broken entirely. All right, well, just assume it's going to come back at some point. It's back! Yay! Okay. Yay, chat is back. All right, good to see you guys again. Glad you're back. So I still can't quite. I can see some chat on the screen, but I can't see it in my Twitch app yet. So hopefully it will come back soon. Come on. Okay, there we go. All right. Well, let's hope it's coming back. I'll see y'all again in just a minute. All right, let's keep going. Oh, Zena, I can see your chat now. Nice. Good. Okay. So again, welcome to all the raiders. Good to see you. Thank you again for the raid, Purple Elf. I apologize if I missed any messages while chat was broken there. Okay. So again, we were talking about how in this case, for storing user data, instead of using an array, we would definitely want to use an object because it preserves the relationship um, between the various chunks of data, what they are, what they're for, and puts them in a certain order. You're not banned, Sketch, and no. What website is that? Yeah, if somebody could link this again, that would be rad. Thank you so much. All right, so yeah, data structures just help us preserve the relationship between data and make it easily accessible. That's the general gist. But the best data structures consume minimal resources while storing data in a meaningful way for various operations. As is the case for most software engineering concepts, though, it is a case of different strokes for different folks. Hence, what is fitting varies with the kind of data that's being handled, right? Like with most things about code, there is really no one size fits all for the types of data that we're handling, right? We always want to find the correct structure for the data that we're handling in that moment. All right, so that's a data structure. Now, what is an algorithm? So the data structure is like the bucket where we're putting our data, right? It's the thing that we're using to hold our data. So what is an algorithm? An algorithm is a process or set of rules to be followed in calculations or other problem solving operations, especially by a computer. So that's interesting that, we tend to think of algorithms specifically as like a computer thing, but it doesn't have to be, right? An algorithm is really just a process or set of rules to be followed in a problem solving operation. So it doesn't have to be done by a computer, but in most cases it will be. And Tucker says algorithm is the logic that gets you from the input to the output. Yeah, essentially. A baking recipe is an algorithm. Yeah. Um, so if you were to get a book at a library and needed to pick the book up for study from the engineering section, how would you go about this? Would you pick up every book on the shelf until you find what you want? We might call that the brute force solution, right? Not really using any sort of intelligent searching or anything like that. You know that if you go into the library and you start looking at every single book off the shelf, eventually you'll get the book you were looking for, right? It just takes time. It might take a long time, but you'll get there. Or would you pick a book at random until you find it, try to find it by alphabetical order, or use a library search guide as a reference? And these are all ways to achieve the goal eventually. You will get there. Um, and all these methods can be broken down into smaller steps that cumulatively achieve the task at hand. And Alma Alyssa says, Mindwolf, are you putting this in your Anki? Everybody should. These definitions of what is a data structure, what is an algorithm. Yeah, absolutely, you should put them in your Anki. And any examples that you might need in order to remember that stuff, right? Luke Polly says, I love algorithms on the Wayback Machine. Yeah, the Wayback Machine is the best. Preserving the history of the internet. Indeed. And Andrea's, that's interesting, Andrea. I like that. They say we use algorithms in healthcare. If this, do that. If not, do the other thing. Yeah, you need proven, proven sets of steps in order to, especially in healthcare, um, to to get the intended result. Yeah, absolutely. When you put a brute force solution into a real world action, it really contextualizes problem solving for me. Yeah. So, if you're thinking about it like in terms of a recipe, um, if you're brute forcing like, a recipe, you might start by, adding individual spoonfuls of, I don't know, of like, of milk or something like that to to a cake recipe, or individual drops of milk and just stirring it, drop stir drop stir drop stir, right, until you eventually you'll get the right amount of milk, but it might take a while. Don Spears says, I'm going to add every ingredient until it tastes like cake. That cake would be a lie. Yes, definitely. I'm hip with the kids. I'm anking as we do this. Yes. Put the flour in every measuring cup until you find the right one. Put everything available in the kitchen into the bowl first and find out what works by trial and error. Yes. All right. And so an example of breaking this down into individual steps, though, would be something like walk up to the shelf, pick up the first book, check if it matches. If it does, yeah, you're done. If it doesn't, drop the book on the floor. Librarians love you. And then pick up another and check again. And so you just keep going until you find the desired book. And this step by step breakdown of the whole process into actionable steps is what we call pseudocode. Pseudocode is a part of what thing that we've been working on lately in class? Where do we know pseudocode from? Yeah, it's part of prep, right? It's that last P in prep. Yes, and it's a silent P, so it's stealthy. Instinctive. Thank you so much. Wow. They even answered the question in their sub. Thank you so much, Instinctive. And they resubscribed with Prime, which is free for all Prime subscribers. You get a free Prime sub. So subscribe to your favorite Twitch streamer. It doesn't have to be me, but it doesn't cost you a dime to use your Prime sub. On Twitch to support your favorite streamer, and also to stop Jeff Bezos from going to space again so quickly. Um, because he made William Shatner cry. So that's not allowed. So stop Jeff Bezos from going to space. Use your Prime sub. Thank you for the hydrate. Yada yada. Thank you for the sub. Mm. Silent P like pneumonia. Yeah, or pseudopod. Yeah, it's that Bezos money. Yeah, spend those Bezos bucks. Slow them down at all costs. Yep. All right. So yeah, we know pseudocode from prep. And at some point, I want to talk about brief tangent here. We've been really emphasizing Leon's really been emphasizing prep as a way for us to solve coding challenges and using it in interviews, and that's definitely valuable. But I've also realized that I use prep in my daily job as a dev. And so I'm not going to get into it now, but I do want to talk about that on a future stream and maybe even show you like a sanitized example of the type of actual prep work that I do in my day job and how we apply prep to build specifications for database tables. I mean, we literally use prep to build these specs. And so I'd love to show you when I need to get permission, from my boss to show the format to show like an anonymized version of a spec. But I would love to show that to you on stream to illustrate how prep is not just for coding challenges, it's for actual work. And so it can help you out if you know what prep is going into a dev job. Yeah. So I need to talk to my manager about that and figure out what I need to do there. But yeah, I do plan to show that on a future stream. It's not just prep. It's not just for Code Wars. All right. So pseudocode is when we break these down into individual steps, and the 4 ways we considered. So again, those 4 ways were picking up every book, picking a book at random, alphabetical order, or using a library search. So those 4 ways can be examined carefully to determine the most efficient, specifically by calculating or estimating the time spent and the energy consumed in the course of searching through each method. So the most optimal solution, or the best one, will thus be the one that consumes minimal energy and takes little time. And so algorithms are just like Granny's recipe book that contains all the steps required to make that special delicacy. So we kind of talked about that already, right? In more technical terms, algorithms are well-defined computational procedures that take some value or set of values as input and then produce some kind of output. And so the most optimal algorithm will be the one that consumes minimal energy and takes little time. Um, all right, and so the main properties of an algorithm. Oh no, time and efficiency. I don't understand Big O. That's okay. We don't got it. Like this is we're just skimming the surface tonight. We're not going to come out of this with a comprehensive understanding of everything, but we are going to get a taste and understand some of the basic terms. So you'll go into Thursday's class knowing what a data structure is in general, and knowing what an algorithm is in general, and the components of an algorithm, so that you can kind of hit the ground running when we talk about it more. Today is day one, exactly. All right. So, what are the properties of an algorithm? An algorithm must possess one or more well defined inputs supplied externally to the algorithm. So, what does that mean? So, these inputs have to come from somewhere else. So, maybe what we do is we declare a variable and then we pass that variable into our algorithm. Could be. Um, so, that could be one example of an external input. That this algorithm must also have an output. So it should have one or more well-defined outputs as desired. So it should produce something, right? So our algorithm doesn't necessarily have to have an input. It could start with zero, but it should generate something because it's spending computational time and space. It's taking up computational time and space, so it should generate some kind of an output, right? Um, and correctness. So every step of the algorithm must generate a correct output. I don't know that my algorithms always always do that. Sometimes they might be self-correcting, like one step is wrong and the next step fixes that problem. But we can be a little flexible. Um, Definiteness. So algorithms should be clear and unambiguous. Thus, every step of the algorithm should be clear and well defined. So we should be able to see, even if it's maybe in a sort of abstract notation, like we can use shorthand, but each step of the algorithm should be clear in its own way. And finiteness. Is it finiteness or finiteness? I don't know. Finiteness? Is it? Oh, I think it's finiteness, isn't it? I don't know that I've ever had to say that out loud. That's one of those words that you read and, finiteness. Okay. The algorithm, finite. Yeah. The last one. The algorithm should have a finite number of steps that should be carried out to achieve the task at hand. So it can't run forever. Um, that's what all those code wars timeouts were trying to tell you. So it should complete at some time. It can't be infinite. Um, the one thing that makes algorithms worth studying is that in most cases there exists more than one algorithm capable of handling the task at hand. Again, in this context, efficiency is key and is determined by considering time complexity and space complexity. So again, time complexity is just how long it takes, and space complexity is how much memory it uses. And so the most optimal solution, again, will use the minimal amount of both. Uh, Mavi says, I'm 100% not an algorithm. As long as you know what they are. Oh, thank you for the prime sub, Tony Stunts. I appreciate it. And TJ Khan mentions, I didn't get through all of it, but that Primeagen class that Leon had us retweet a few classes back is really good. Yeah, I actually haven't had time to get through that, but I do plan to. Went through it using basic terms I could understand, such as loops. Even if you don't understand the syntax, you could get an understanding of Big O. So yeah, don't forget about all those things that Leon has us retweet, or like and that kind of thing on Twitter. Those are, again, more resources for you. Oh, thank you for the hydrate. I'm about out of tea. Okay, so we know what data structures are. We've seen some examples. We know what algorithms are. We've seen some examples. We know what the main properties of algorithms are: input, output, correctness, definiteness, and finiteness. Try to say that 5 times fast. You can't. And so we know what those are, and we know what an optimal algorithm should contain. You know, uh, the best time complexity and the least time complexity, the least space complexity. So definitely put these things in your Anki and start referencing them. Um, and that's just kind of an algorithm, data structured algorithms class crash course, getting us familiar with some of the terms and some of the concepts. I'll stick with input and output. Yeah, Primogen is great. Absolutely. Triz's, yeah. So I'm trying to be kinder to myself, and so I'm on these Wednesday streams, especially since I have work tomorrow. I do try to wrap up within 3 hours. So at 10 p.m. Eastern, we'll be ending the stream. So however far we get is however far we get. But yeah, 10 p.m. Eastern. So in about 2 hours, we'll be wrapping up. Hopefully that helps you plan your study time. Hey, Chai, welcome from Mexico. Jazzy Pants says, definiteness, shouldn't that be definition? No. So in this case, that is so when something is definite, that just means it's clearly defined. So it's just an odd way of saying it. So that is a word, but it's a little bit of a clumsy word. Yeah. Self care. Yeah. Self care is good. All right. So, just to quickly summarize before we go on to the next section, just like a library organizes books in a meaningful way for easy and efficient access, computer programs organize data in various ways too. This is so that computer processes can access and use them easily and efficiently. And at the library, there are various ways to search out a book, some more efficient than others. In computer programs, there are various ways to manipulate data and get tasks done, algorithms. For these two, some are more efficient than others, and efficiency here is determined by considering the time taken and the amount of memory that is used. So, why do we care? So, modern day applications are data driven. Intrinsically, at the basic level, they tend to do these four things: they accept data, they store data, they process data, and they output data. And handling that data efficiently, uh, in many cases, goes beyond the capabilities of existing data structures that come packed within a language. It's a software engineer's responsibility to create models of the problem domain at hand so that data is organized and manipulated in a consistent manner with some respect to the problem at hand. And so if you think about, um, data never goes away, right? Data data is forever, right? And so databases and the amount of data that's flowing around is only ever going to grow. We're only going to keep capturing more and more and more data. And as someone who works with databases every day, I can tell you that nobody ever, you never get rid of data. You might archive it, or but the flow, the influx of data is constant. It's incredible the amount of data that is being captured at all times, and has to be processed and dealt with. It's just the volume is tremendous. And so we have to think about how that data is interacting with our applications. That's just going to keep becoming more and more important. Data is forever. And Scotty replied, Brent Spiner likes this. And Ominous Lurker says, data lasts forever unless it's your business's data and you, the person in charge of it, didn't make backups, which is the only kind of data that can disappear forever. I will say, even data recovery is pretty magical. I've seen it work. I've seen somebody make a disastrous choice in a production database. Not me. It wasn't me. But some other poor sap. I watched them make a disastrous choice in a production database, and uh, data recovery is pretty magical. I will say that. No, it wasn't. It wasn't me. Not me. But it was a person who we called the butterfly effect for like the entire rest of the time I worked there. The shaggy defense. I have to tell you all that story sometime. Okay, so why data structures? So often we need to handle complex data results in the creation of abstract data types, which are designed to create a logical description of how data is viewed and the operations that can be carried out on them. These abstract data types allow us to handle data more efficiently, such that we worry about what the data represents and not how it is constructed. This is known as encapsulation. And we've heard that word before, right? We've heard of encapsulation. Examples of such data types include the array, the list, the map, queue, set, stack, table, tree, and vectors. And they just provide it. They just provide buckets to put our data in, right? And they also give us some sort of built-in operations that we can perform without having to build our own, right? We have all these built-in array methods within JavaScript, and we can just use those to work on the data once it's stored in an array or in an object or something like that. So why algorithms? A fundamental understanding of various algorithms and data structures better equips a software developer to use them properly. Software engineering is learned and mastered through practice. Y'all know this, right? I hope you're practicing. So, an examination of different problem solving techniques better prepares you to handle challenges in the future. And it's not just about getting the highest score on Code Wars, right? It's about oop, so I think there's an Amber Alert on my phone. Hang on, it's just a really loud beep. Why are you beeping? Okay, yes, lots of practice, exactly. So eventually you start to recognize patterns, right? And that helps you transfer your knowledge and understanding across various domains and problem sets. Um, so, yeah, after a while with anything, like with anything, you start to develop muscle memory and you start to notice patterns. For example, for those of you who are caught up with the course and have been, doing the homework so far, you can probably look at like the code for a CRUD app and understand the basic structure, right? You kind of know the basic components that we need, right, to build a CRUD app. You recognize where the models are, you recognize the views, you recognize the controllers. You may not understand all the code that's inside of it and what every single thing does, right? But you could look at it and you could see the pattern. And so that's what you start to get, right? MVC, baby. Yeah, pattern recognition requires lots of practice, but you can even after a few repetitions, you can start to see it. All right, so a primary concern when dealing with algorithms, as earlier noted, is efficiency. How do we determine the efficiency of a given algorithm? There are two stages at which algorithmic efficiency is evaluated. That's another tough sentence, thanks. Two stages at which this efficiency is evaluated. You can think of this basically as one being a theoretical analysis and the other being practical. So we have two types of analysis, priori and posteriori, which is a wonderful word. So, what is priori? This is the theoretical evaluation, which factors such as processor speed are assumed to be constant and are not considered as having any effect on the algorithmic implementation. So, just like with a math problem, right? With like a word problem that you would do in math class, um, it would say, it might say things like, uh, friction doesn't exist, or I don't know, air resistance is zero. Assume no air resistance. And so in this case, with this priori, this theoretical evaluation, processor speed doesn't matter. You're estimating, right? It's an estimate. Um, and thank you for the sub, muckety muck. I really appreciate it. And another Prime sub. We're gonna delay Jeff Bezos getting to space by another whole second. Go us. Hey, every little, we're just chipping away at it, right? Chipping away. Yeah, prior analysis. So priori is actually a word, but yes, it basically just means prior analysis. Yeah, theoretical evaluation. So posteriori is the practical evaluation that's carried out by implementing the algorithm using a selected programming language. So basically, running the thing. So first you have your hypothesis based on what you know, and then you actually run it and see how it does. The algorithm is then tested on a computer while observing the time taken and memory consumed. So priori analysis makes use of asymptotic notation. It's a standard way of expressing an algorithm in terms of its time and space complexity. This is due to the fact that these are characteristics that cannot be measured or compared directly. And the most commonly used type is the one I think we've all heard of by this point, David Knuth's Big O notation. And so I think we've probably heard that word. People talk about it, that kind of thing. And so um, that's kind of how we can make these guesstimates about how well something will perform. Um, Posteriori sounds like the Latin word for butt. Yeah, absolutely. Madeline says, I love Mind's glee to take seconds off of Bezos' mission. Yeah, absolutely. The dude's, the dude's, I would use words to describe him that I'm not going to say on stream. So, yeah, absolutely. I'm gleeful about it. Use those Prime subs. You don't have to use them on me. Use them on somebody. Just spend Jeff Bezos' money. Spend all of his money. Drain his bank account. Fjord says, my philosophy degree is coming in handy. Yeah, you never know. I mean, having a good understanding of word origins, etymology, word construction can come in handy in so many different ways. I was an English minor in college, and definitely comes in handy sometimes. Big selfish jerkhead. There you go. I like that description. All right, so big O notation. It's asymptotic notation. It's an example of theoretical evaluation, right? So big O notation is known as the upper bound of an algorithm or the worst case. And it tells us that a certain function will never exceed or take more than a specific time to execute, irrespective of the value of the input. This is considered a very effective way to approach analysis, as it is able to tell us how our algorithms will perform in the worst case, perhaps with a very large input. And so, from what I've seen of uh, this course so far, it doesn't really get deep in the weeds about big O notation and how we use it. But at least now we know. Okay, what is it? Well, it's big O notation is just the upper bound of an algorithm, or how our function will perform in the worst case scenario. We're good at breaking things. We got this. Absolutely. All right. So again, data structures help us organize data, and algorithms manipulate that data. And we're going to learn some analysis techniques that will allow us to compare various solutions based on their own characteristics and not the characteristics of the overall program. We will often do a posteriori, so afterward, running the code. We'll do a posteriori analysis in order to ascertain the efficiency of the algorithms considered. However, the results of a priori analysis will be considered in fitting cases. In the end, as usual, there often exist multiple approaches to solving a problem. As a software engineer, it is your responsibility to explore these solutions and then test them to decide which is fitting in each situation. And this is a recurring process indeed. This course is designed to help JavaScript developers do just that. And so there's some further reading down here. You can look at that if you want to. But what we're going to do after the break, so we're going to take a 5-minute break. And when we come back, we are going to learn the tools. We're going to set up some tools that are going to help us run test cases in VS Code and do benchmarking, so speed testing of the various algorithms that they're gonna cover in this course. We can learn how to speed test those in our browser using a browser tool. Um, hey, blah, welcome. You came just in time for our break. It's the top of the hour. So if you're new to this stream, we like to take a break at the top of every hour to be healthy. And so, our eyeballs don't fall out of our skulls because we've been staring at the screen so long. Also, I know that I need some new tea, or some fresh tea. So So, Blah, if you're willing to stick around, like I said, when we come back, we're going to uh, get the repo for this course going in VS Code, and we're going to learn the tools that we're going to use in order to um, get the most out of the course. Now, like I mentioned before, one of the limitations of the Wayback Machine is that certain features can be missing. So, links can break. And in this case, a couple very important links are broken, and I have solved that problem for you. So you're welcome to continue on the course with your to continue with the course on your own, but I do want to get you set up for success by giving you the tools that you need that aren't necessarily available anymore within the course itself. So stick with me after the break, and we will learn how to do that. From which website is the course taken? If you let's see, I think it's been a little while since somebody linked it, so I will share that with you here. Um, yeah, it's a course that's no longer active. However, again, through the magic of the web archive, we can still access it. However, like I said, there's a few key features that are missing, and so that's what we're gonna set up after the break. All right, I'm gonna put 5 minutes on the clock. Come back in 5 minutes. Learn the tools that you need to successfully complete this course. Um, and then we'll start on it together. Like I say, we aren't going to do the entire thing tonight, but we are going to get some inroads, and you will be able to um, hopefully do the rest yourself. All right, 5 minutes on the clock. Reset that for you. Go get a drink, go stretch, stand up, sit down, whatever you got to do, and I'll see you back here in 5. All right, folks, we got about a minute left in the break, so make your way on back. Get yourself a fresh cup of water, pet your dog, do one last stretch, um, roll your wrists, stretch out your fingers, don't get carpal tunnel, and come on back when you're ready. Leibniz says a deleted algorithm course sounds ominous, and TJ Khan is absolutely right. This course is only on the no longer available just because the creator sold it for presumably a large amount of money, and sold their website. And so their hard work was rewarded. We just can't access the course anymore. So, but again, that's what the Wayback Machine is for, and why it's such a great resource. All right. So, welcome back, everyone. Let's get back to it. So we talked about the theoretical stuff, right? We talked about all these terms and vocab, and now let's learn how we can actually get a little bit hands on and get set up in order to do that. So we're going to go to the next section, which is called tools. So let's make our way over there. Thank you for the follows, folks. I really appreciate it. Thank you for the follows. Thank you for the subs. It's very generous of you. Thank you. All right, so what tools do we need? Well, in this section, we'll highlight the tools that feature prominently in this course and examine their relevance to our overall objectives. All right, so code editors, obviously, we know there's several. We're going to be using VS Code. You can use whatever editor you want, but we are going to be working within the context of VS Code for these examples. And that's what they are going to be using as well. They'll be using VS Code. So if you're a Vim expert and and you want to power through using Vim, more power to you. But I just figured out how to quit Vim like a week ago, so I'm not going back in there. All right. Ulpra says vanilla notepad for those living on the edge. Let me tell you, I didn't even know. So I didn't even know what code editors were. I didn't even know what VS Code was. Like really until I started 100 Devs. I didn't know what it was for. Previously, I had always written my code in like a text editor, like Notepad plus plus, or or just directly in like uh, Microsoft SQL Server. So yeah, I didn't know what a code editor was. Notepad plus plus is the bomb, I gotta say. Built different. Yeah, no, I always just did it. Yep, I wrote it directly in SQL Server or PL SQL or in Notepad plus plus. Yeah, living on the edge. That's how I roll. Notepad plus plus is pretty baller though. It's pretty great. Yeah, there's tons of stuff I don't know. That's the best thing about being a developer is that you always never know anything. Like you're always the least. There's whenever you get three developers in a room, everybody's gonna know like have completely different things that they know a lot about, and so it's the best way to share knowledge. All right, so we're gonna be using VS Code for this. Um, Making sure that our algorithms work. So just we're going to be using Jest for that. So test cases. You may have seen test cases in Code Wars. Um, and so basically all a test case is, right, is it's just you've written something, you've written some code, and you want to test specific implementations of it. Um, so we're going to be using Jest, which is an open source project maintained by Facebook, and it's especially used for testing React applications, but can be used for testing any JavaScript code. It's fast, it can do snapshots, and it requires very little configuration. I always like that. And it's packed with powerful tools out of the box. Um, So we'll get to, how we install that and everything in just a minute. In this course, we'll use Jest to set the requirements for the algorithms and then test with it to see if we have successfully fulfilled all requirements. You're probably familiar with that from Code Wars, right? It also enables us to compare various algorithms to see how they perform. Um, yeah, exactly. As Rascal said, anyone who uses Create React App gets Jest added for free. Yeah. Yeah, whenever you do Create React App, and it installs a bunch of stuff and takes forever, one of the things it's installing is Jest. Yeah. I'm going to be able to add Jest to my resume. Yeah, absolutely. Do it. In 3 seconds, the tutorial tells you to yeet it. Yeah, the Traversy tutorial. You install Jest, and then Traversy tutorial was like, and get it out of here, as is tradition. All right, so checking algorithm performance. So it says here we're going to be using JS-Perf. Hooray! But if you were to try to go to jsperf.com, let's do that. Uh-oh. It ain't working. And a little Google sleuthing told me that unfortunately this tool is no longer functional. So never fear. Never fear. We have an alternative. There is an alternative to JS-Perf, which we can use instead. Now, this isn't like super critical that that you do this part, but we're going to be using jsbench.me. And so I will paste that link in chat for you. So jsbench.me will allow us to do our benchmarking and test cases just fine. I think in a similar manner to JS-Perf, although I've never used JS-Perf. Either way, it still performs, it still does it still does what we want, right? And so that should work just fine. As you're working through the course, you should be able to run these benchmarks in jsbench.me. I'll show you how to do that once we get to the first one. I'll show you how to set this up and run it, and everything should be fine. All right. Yes, and so in this case, what we're going to do with JS-Perf, or JSbench.me, is it allows you to benchmark JavaScript performance within the browser. So it's specifically browser based, and it allows us to test different code snippets to see which is faster, and it just says how does our code perform within the browser. Yeah. So just a different implementation. Rather than doing it straight in VS Code, we're going to do it in the browser as well. So what Jest is going to allow us to do is create some test cases and see if our code passes those test cases. Yeah. So with the one we can set up some test cases, and then with the benchmarks we can compare various implementations of our functions and see which ones are faster. So we'll apply this in a minute, and yeah, we'll apply this definitely. So you should see the difference there. All right. So how do we set this up? So the algorithms and data structures in the course are organized in 3 levels. Really, I think the only thing in this implementation of the course is just the beginner, but beginner is plenty. there's no shortage of options here, so that's okay. And it says, don't feel discouraged. This is something important to note. Don't feel discouraged as some of these challenges are a little difficult. Working through projects that we don't know at first leads us to become better developers. I think we all know that. We all know that at this point, right? Beginners, yes. Yeah, no, yep. Everybody's got to start at the beginner level first. At least they warn us. Exactly. At least they warn us, unlike Shay Howe, right? Okay, so every article from this point will sufficiently explain one algorithm or data structure at a time, consider various implementations, and test for efficiency under the following sections. So we'll start with a challenge. We'll learn how to think about it algorithmically. We'll do some code implementations. We'll do some testing with Jest. and then also some testing with JS Bench. And then we'll see. So my favorite part is then we'll get to see some practical applications to tell us, okay, theoretical exercises are all well and good, but what the heck would we actually use this for in the real world? So that's my favorite part. Um, and then a conclusion and some further reading if you want. And so the code. What code are we working with? Well, the code for the course can be found in this repository, and there is no link here. It says this repository, and there's nothing to click on. I think there was originally probably a screenshot here or an embed, and that is no longer present. So don't worry, I got you. I found the repo. It's right here. You didn't think I would let you down like that, do you? All right, here's the repo. Oh, is there a button? Well, I found it anyway. Does this take you to the same place? Yeah, so it takes the same place. Good. Ultimate guide. I think that's the same one. I'm just double checking. Is it? Either way, I mean, I did check the code. It's correct. So this one looks like a slightly different. Okay. Well, either way, it doesn't really matter at this level. It's just the basic exercises. One's wrapped in the Wayback Machine. Oh, yeah, that's right. Yep. Good call. So this is the current one. Yeah, because one is a Wayback Machine link, and so you got to be careful about that. When you're clicking on any links inside of something in the Wayback Machine, it will take you, if it can, it will take you to another Wayback Machine link at a similar time period. So you're going back in time. So if you want the real link, you need to remove the this web archive prefix from it and just go to the URL. So see, this says web archive. If I take that off, that'll take me to the current version. So just be careful whenever you're clicking on web archive links. All right. That'll teach me to ignore a big red button. Either way, it takes us to the same place. Okay, so that's the code that we need. And what we can do, what we can do, like Mavi said, is we can go ahead and clone that repo by opening up our VS Code window and just cloning it. And you can fork it too if you want. If you want to have this to store this repo and manipulate it and do stuff to it. I'm just going to clone it in this case because I'm just going to uh, be playing around with it. I might fork it later, but for this demo purposes, I'm just going to be playing around with it. All right. So once you've cloned it, you should see that you now have your choice of folders. And so we'll get to what we need to install and executing things here in a minute. But for now, just make sure that you have access to it. Forked and clone. Nice. Yeah. Grab it. Absolutely. Okay, so what is in the code? So we can just kind of look at it for now. Each algorithm and data structure will have its own folder, and in there you will find 3 files. So we can see here as I expand this list, we can see that each exercise, so if I zoom out a little bit, we can see the exercises here. On the left sidebar, there's a bunch of different algorithms, and those are reflected in each of the files here in the code itself. So for example, the first one is string reversal. So if we were to look at reverse string, you'll see that there's 3 files in there. And the first one is called start.js, index.start.js. And this is an empty file where we can write our own algorithms and test them out as we follow along with the course. The next one is the solution. Fairly obvious. It's the solution to the problem. All the solutions for a particular challenge as discussed in the article. And the last one is called test.js. And what this is just contains the tests with which we would validate our algorithms to see if they pass for every case specified in there. So, and we'll look at each of these as we get into actually get into our first algorithm. And Madeline says, I wish we could download Code Wars problems like this. Yeah. Well, with Jest, you can write your own test cases in VS Code if you wanted to, right? So algorithms are just JavaScript put together into one. So yeah, yeah. So algorithms. I don't know if you were on for the first part of the stream, but um, I would suggest checking out the first part of the VOD because we go into a pretty lengthy description of what do we mean when we say algorithm, right? So an algorithm is basically just an input and an output that performs some kind of an action, right? Um, and so with a series of steps, you can break it out into a series of steps. It takes something in and it puts something out. And so what do we know that does that in JavaScript? Well, it's a function, right? A function could do that, among other things. And so, yeah, it's really not as complicated as it seems. No worries, Madeline. That's totally fine. I understand, folks come into the stream at all different points. And so, yeah, I more like a suggestion. Oh, but yeah. But yeah, that's why I record. That's why all my streams are available as VOD, so you can always rewind at any point, and catch up where you miss. So if you didn't know that, if you're new to the stream, my streams are always available as VODs. And before they expire on Twitch, they move to YouTube as well. And by the way, I will be. Finally got done doing what I need to do with all of my streams from my backlog from September all the way up to the start of October. Um, so I've ported those over to YouTube, and I'll be making those public as soon as they finish processing this evening. Hey, Snickerdoodle. Yeah, so we're just getting a basic introduction to data structures and algorithms this evening. We're really just covering the basics of terminology and learning a few basic algorithms and how to test them. So nothing complex tonight. Just getting an introduction to what they are and some terminology. All right. So when we do run tests, how we will run them is just by saying npm run test and then the folder name that we want to run. This will run the tests and present you with a result, which includes how many cases passed, how many failed, and how many seconds it took to execute. So again, we'll see that when we actually run one. If you aren't experienced with running tests, don't feel wary. This is optional. However, we would highlight the results in every case so you still get to learn from them. Unfortunately, again, a limitation of Web Archive is that a lot of the images no longer exist. So we will be running a lot of these tests ourselves just to see them because the images are gone. All right, so how do we set up? Snickerdoodle, I love that you said that. So Snickerdoodle says, I'm an infrastructure engineer who never had a comp sci background. Me neither. Most of the scripting and coding I've done is something I've picked up at work or home. So this is something I need to learn. Yes. And I'm exactly the same way, Snickerdoodle. So I am so in my day job, I am a senior SQL developer. So, but I don't have a comp sci background. Um, I have a degree, but it's not in anything related to computer science. Everything that I've learned in coding, I picked up on the job, just like you. So I don't have any kind of background with data structures and algorithms. And yeah, I'm missing that bigger picture, that theoretical sort of mortar that holds all this stuff together. So I'm glad we're in the same boat there, Snickerdoodle. Yeah, absolutely. And so I love that you said that also, Snickerdoodle, too, because I feel like a lot of folks outside of tech, kind of think like, oh, devs, in order to be a dev, you have to know everything, right? And you got to know all the theory. You got to have a CS degree. You got to know, why something works and not just how to do it. That's not true. I can speak from experience. I mean, you just gotta, you can be a dev and still have big, quote unquote, holes in your knowledge, in your theoretical knowledge, and you can be good at being a dev. And have holes in your knowledge, but it's never a bad idea to try to fill those gaps when you can. Loggerhead. Thank you for sharing that, Loggerhead. They say, I flunked high school and am now a dev going for senior. Absolutely. Yeah. There are no limitations to this field. Anyone, if you you can do it. I guess it's just like that's you shouldn't have these theoretical barriers to entry, right? If Loggerhead can do it, if Snickerdoodle can do it, if I can do it, you can do it too, right? So I love that you all said that. Snickerdoodle says I flunked college. Yeah, absolutely. So just Steven says get fork or clone. So in my case I just cloned it because I'm not like you know I'm I'm just going to be running, to tests on this. I'm not really going to be making any changes to this repo at all. We're just going to be just saving some things, running some tests, no material changes. But you're welcome to fork it if you want to. Um, that might be a better idea if you're going to be, long hauling and doing the whole course. You might want to fork your copy. And Blip says, according to Reddit, if we aren't CS grads with 5 years of working experience before graduating, we don't got a chance. I think Snickerdoodle, Loggerheads, and I can all say that that is absolutely 100% not true. Leon is teaching us, so when in 100 devs, Leon is teaching us all the reasons why that's not true, right? And we have so many people that can speak from experience here in chat and elsewhere that can also say that that's not true. Don't believe it. Yeah, it's about are you willing to put in the work? Are you able to learn? Are you flexible? Do you show aptitude? Yeah. Oh, can you go over where you cloned? Yeah. So I mean, all I did was just open up a new window. So in VS Code, I just opened up a new window, and I just said on the introductory window here, I just said clone git repository and just dropped in the URL for the git repo. That's all you got to do. It'll ask you where you want to save it. Um, just save it wherever you want to, and then open it up, and it's ready to go for you. And you can fork it first if you want to as well. It's probably true if you have the social skills of a typical Reddit denizen. Yeah, and that's we talked about that a lot on stream, right? Is that a big part of getting your way into the field is, you know, being able to talk to other humans in a reasonable manner, right? It's not so much about how many languages you know or how many applications you've submitted. It's about can you show that you have the personality to have a meaningful conversation with others, and can you interview well. We talked about that a ton on my last stream. So if you're interested in learning more about doing better at interviews and getting that aptitude, feel free to check out my previous stream, and because that's a big part of this. Cafe brings up another great point. You'd be surprised at how much being a nice person helps. Yes, just being nice, but also not uh, being nice while being assertive, and that can be really challenging sometimes. Being nice and being assertive will get you really far. I'm trying to convince my brother to switch from traditional engineering to tech. He knows C Sharp, C, C++, and does a ton of VBA to automate stuff. Yeah, VBA is great. He's overqualified for a lot of jobs, but has big time imposter syndrome. Yeah, and that's another thing that's hard to overcome for folks, too. I hope you're able to convince him because it sounds like you'd be a great fit. Hey, and D5 with another example there. No CS education, 20 plus years with Oracle, all the way up to principal QA engineer. Yes, absolutely. And Madeline makes a great point there, and I've that got caught by the spam filter, but I've allowed it because it brings up a good point. Um, Being assertive is sometimes hard for women because we don't want to be labeled as a bee or bossy. Yeah, that can be difficult. It's a hard line to walk. But Sometimes I think it's worth walking. Yeah. It's a fine line. Absolutely. Yep. I'm going to hydrate real quick. All right. So I love the conversation. And if you want to, again, if you want to learn more about, how you can be better at answering interview questions, how you can be better at answering behavioral questions in interviews, because that's going to be the majority of them. Again, feel free to check out my previous stream. Go to my Twitch channel, check out my videos, and look at the stream just before this one. And we spent a good 3 hours talking about all this stuff, and it was just a fantastic conversation. And I also gave you I also gave some suggestions on how to answer those types of questions, regardless of your background. So hopefully you might find that helpful if you missed my last stream. And Blah brings up another great point. Um, Being assertive also improves with practice. Yes, 100%. And the hard part of that is building up the inertia to practice interview questions, um, to practice speaking your mind um, in a constructive way, right? Without becoming, you know, speaking your mind before you get angry can be hard for some folks. You bottle it up, and because you don't want to make a you don't want to make a scene, you don't want to make a scene, and all of a sudden you get angry, and then you speak your mind, and then it becomes a problem. And so that can be really hard for some folks. Um, yeah, and again, like Blah said, it does practicing helps. Learning to speak up in meetings, learning to speak up in groups, and so that's why on the Discord or on in 100 Devs, whenever there's an opportunity to do a group project, please try to attend and try to contribute as much as you can. It might not go well, but you're getting that practice in, and that's a big part of it. Because yeah, I used to be so quick tangent. I used to be a doormat. I would not speak up. I would just go along with what everybody else said because I thought that would make people like me. Because oh, if I just do whatever they say, then I'll be good. Everybody will like me. Um, but I find that people like me more when I come up with constructive responses and well thought out questions that might challenge some of the things that people are stating. If it shows that I truly understand what they said, and uh, I'm adding to what they say by either answering a question or contributing my own thoughts, then people see me as a valued contributor rather than just somebody they can always have on their side and just drag along with them, right? They see me as they see me as helping to pull the wagon rather than just dead weight. Yeah, learning to be an advocate for yourself is a journey, and sometimes you might not be able to do it, and that's okay. It's something that you work on. It's something that you practice, and it's a constant practice. You're forever getting better at it. All of a sudden, you'd be making a scene. Yeah. Constructive and positive are the keys. Absolutely. It's the not what you say, it's how you say it. Being assertive without being seen negatively. That's yeah, again, it's a skill. And Devdi says the whole asking the interview questions and asking the recruiters questions made me feel uncomfortable. What if they reject me for asking too many questions? That's not likely to happen. As long as the questions that you're asking are well thought out, again, and make sense, then what they're likely to see is that you're engaged, and that you're not just that it's not just another interview for you, that you're engaged with them, you're thinking critically about the problem, and that you're able to articulate yourself um, in a coherent way, right? You're able to phrase questions logically, and that's really important when you're a dev. You got to be able to speak and think logically. It can be tricky to have self awareness of how you come off to others. How do you stay in touch with reality? Um, so sometimes just recording yourself and seeing how you sound can be a big thing. And also speaking to others on the Discord. So getting in those voice channels and talking to others. So recording to yourself, listening back. How did I answer that question? Did I make sense? Do I sound okay? Um, and also just, yeah, getting honest feedback from others, from strangers on the Discord can be really good. They give constructive criticism without, you know, trying to sugarcoat it like your family member might. one of my mentors told me to realize you're also interviewing them during the interviews. Yeah, so you are interviewing the interviewer just as much as they are interviewing you. Absolutely. Yep. Yeah, the best way to see how you sound to others is to practice. And the Discord is a great place to do that. And the voice channels, um, yeah, just getting out there and talking to people. After I do a stream, so here on Twitch, after I do a stream, I often go back and listen to myself at key points to see how I sounded. Did I explain that well? Was I speaking too fast? Um, you know, was there something else going on that I didn't realize, that maybe I wasn't explaining things well? So I often go back and listen to myself after I do a Twitch stream. I won't watch the whole thing, but I'll go back to key points and see how I sounded and where I can improve. Okay, but yes, again, definitely check out my previous stream if you want to hear more about, doing well at interviews, how you can answer behavioral questions better, all those different things. And we're going to do more future streams on this too during Huntober. This is not the last time we're going to be talking about that. Um, we are going to be, you know, talking more about interviews, talking more about how to talk positively about yourself, how to construct your background to fit, those behavioral questions. And yeah, we're going to be covering more of that definitely. My streams are like 5 hours. Yeah, I'm not going back and watching the whole thing. I've already seen it. I lived it. Yeah. Oh, thank you, Full Moon. I really appreciate it. Welcome to the stream. Okay, so that was a wonderful tangent. I love talking about that stuff, but let's keep going with algorithms. And I promise we will talk more about interviewing, about confidence, about about how to function, within a development environment. Definitely more in the future. Okay, but how do we set up to get ready for running these algorithms in VS Code? So I'm assuming that most of the folks here already have Node installed. Um, if you don't, you can definitely go install it. I wouldn't click this link because, again, it's going to take you to a web archive link. However, if you do need to install Node, I would suggest you go to the Node website and download it there and install it. You might have to come back and rewatch this as a VOD if you do need to go install Node. Um, but yes, you will need Node for this. Oh, Lo Polly, you're going to the next interview. That's awesome. Good job. All right. So we've already cloned. We've cloned out the repository, so that's done. Go us. And this is just telling us how to, if you need to update your local copy, you can do a git pull in order to do that. I don't think this is being updated anymore, considering the whole course is deprecated, so we don't have to worry about that. But what we do need to do is go ahead and install our various packages that we have here. So we can see what packages we're going to be installing by clicking on package.json. So I've opened the code file here, and by looking in package.json, we can see what we've got going on here. So looks like only a couple things. But another thing to note here is that we have a script. So normally when we would run a script, we might type something like npm start or npm run dev, right? But in this case, our script is going to be just test. And what it does when we type test is it actually runs jest. So test runs jest. All right, and so let's go ahead and install our dependencies. So I'm going to go ahead and open up a terminal here. TJ says no contributions in 4 years to that repo. I think we're Gucci. Yeah. All right, I'm going to open a terminal. I use Bash. You can use whatever you want. But in order to install those dependencies, we can just type npm install, and it's gonna yell at you a little bit. It's gonna say things are out of date. That's okay. Don't worry. It still works. We're just gonna roll with it. So npm install. And it's going to give you all sorts of warnings. Oh my God, everything's deprecated. Ah. But that's okay. It still works. We're going to be fine. Hey, Carla. Yeah, so I did clone the repo a while back. Um, so yes, I cloned the repo, and I just have it open here in my VS Code. Yep. And in order to clone it, you can just open up a new VS Code window and click on the clone Git repository link here, and then just so it'll give you a little drop down, and you can just put the URL right here into the box and clone it. Easy as that. Doesn't have to be hard. You don't have to use the command line. You can if you want. You can use the command line if you want, but I like to use the built-in function in GitHub that just allows me to clone it directly from a URL like that. 56 vulnerabilities. Oof. Yeah, it's okay. We're gonna be fine. It's all right. We'll live. All right. So once you've installed, everything should be set up, and we should be ready to go. So it says there's 3 different ways you can take this course. Simply read and hope it'll stick. Now, we know that that's a bad idea, right? You shouldn't just read it and hope it'll stick. Um, and they even say, please don't do this with a sad face emoji. Or you can go through the content of each article and practice after, or you can practice as you read through and ensure you are getting similar results. So, what they recommend is practicing every algorithm considered on your own as you go through the course. And don't copy code, write it out yourself. Read up the linked articles. Provide feedback. No, we're not going to do that. This course is deprecated. And try more solutions. So if you think of another solution, you can try that too and benchmark it against the others. Please don't do this. Yeah. Yeah, and how you do it is, you can do it however you would like. The important thing is that you do it, right? Okay, so let's go on to our first algorithm. Now I'm going to change my window widths here a little bit to put a little more space on the screen there. All right, come on, baby. Go, go, go. Okay, phew. I'm glad it worked. It might be getting a little, this page might be getting a little bit more traffic than it's used to. That's okay. We'll live. Yeah, it's okay. This repo is old. You're gonna have some vulnerabilities. You can try doing audit fix if you want to. I didn't bother, and it still worked just fine. So it's all good. Okay, so string reversal, and this is probably something we've done before, right? But I don't think we've ever looked at it algorithmically. So the string reversal algorithm is perhaps the most common JavaScript code challenge on the internet. So, what that means is that it's probably pretty common in interviews as well. So, it's something you should know front, back, and forward and backwards. In this article, we explore various techniques. As a good number of string manipulation algorithms are dependent on one's ability to reverse a string. Okay, so we're going to look at a bunch of different ways, and then we're going to test all those different ways against each other. So you should already have your development environment set up. We did that. And we are going to go into the beginner folder, and we're going to navigate to the reverse string folder. So right here, there is a folder called reverse string, and our work for this challenge will be done in here. Make sure to follow along in the index start file. So they give us a lovely file here where we can write our code. Looks kind of similar to a Code Wars, right? Don't worry about running npm audit or any of that stuff. It'll still work. It'll just, like Rascal said, it'll work as is. I mean, you can if you really want, but I wouldn't. I would do that maybe, like, if you're going to do that, maybe do that after the stream so you can still follow along. But it's not going to break anything. Yeah, it's all good. We gotta live. So you gotta live with your personal vulnerabilities and with your code vulnerabilities. It's very, like, I don't know, existential. Learn to live with your vulnerabilities. You'll be fine. So zen. Yeah. You know me. Living on the edge. All right. So the challenge: given a string of text, write an algorithm that returns the text received in a reversed format. So if we run this function, we should expect that if we put in the word algorithms, it will return the word smitugla. Cool. So the process here is so the first thing we're going to do is think about it in terms of algorithms. All right, so the process here is simple and straightforward. Our function will receive only one parameter. So we're kind of doing like pseudo prep here a little bit. So we're expecting to get one parameter. And we need to manipulate the characters in the string locally, and what we're returning is the string in reverse. And they've given us an example here. So algorithms should come out smrturgala. So we know what's going in, we know what's coming out, we have an example. And so let's talk about the code. My favorite thing about this is that all of the important screenshots, like in like snippets and stuff, are all broken, but the only thing that's preserved is the GIFs. So we get gems like this that are perfectly preserved, even though all the important stuff is gone. Let's get weird, indeed. Okay, so for this particular challenge, we're going to explore 4 ways to solve the challenge using built-in methods, using a for loop, using recursion, which we may not have touched in a while, or using reduce. So for the first one, we're going to do chaining built-in methods. Now, this is the one that probably a lot of us might be familiar with. So we know that there's a ton of built-in methods, and if we just chain them in the right order, they can take that string, flip it, and reverse it, right? Split reverse join. Yep. Our good friend, the old split reverse join. Yes. So again, you're probably very familiar with this, but we're going to implement it anyway, and then we're going to look at other ways to do it, and then we're going to see which one is best. Jiffy will outlast us, might throw it in her resume. The bop it method, indeed. So we're going to use split. It's used to split a string into an array of characters. It received one argument which specifies the separator that determines where every split occurs. So could be a comma, could be a dash, could be something else. The reverse method reverses the order of the elements in an array. And then the join method takes that array and combines it back into a string. It receives one argument and specifies the separator. When none is supplied, it defaults to a comma. Okay, so this is your classic Code Wars one-liner solution, which we should probably all be familiar with at this point. But again, this is the type of thing that you just gotta know, right? And so practicing it doesn't hurt. Split and reverse. Let's see if I can type and talk. Apparently I can't. Reverse and join. All right. Cool. Or if we want to get fancy, we can use ES6 syntax to make it a little better. And as we got some folks guessing on which one is going to be fastest already. So we shall see, won't we? And Leibniz says the most obvious way for someone who never touched JavaScript like me is probably recursion. Yeah, if you're coming from another language, this might not be the most obvious way. Hey, Justo, respect for instructing people into coding. Yeah, this is the best way to learn is to teach, and so that's why I like doing that. Hey, Brownie, welcome. Brownie Slap. I love that name. Great name. All right, so let's do the next one too. So we can I'm just going to copy and paste this and drop all these in so we can look at them at the same time. So return text. So instead of doing the split, we can just use the spread operator, which is another thing we should be familiar with, right? We saw that a little bit in React when we looked at React. We saw that the spread operator gets used quite a bit. So we should know what this is and when to use it, when we can use it, to take our string and pull it apart. I like to think of it like you're pulling apart an accordion or like a piece of fresh bread, right? You're just splitting it out into its individual components. All right, so that's another way to do it. Or we could use a for loop. So let's look at this way. All right. So we declare our result. Now this isn't like this is another way of thinking about this type of thing, right? Because we a lot of us are really used to trying to figure out that one line solution. So because Code Wars likes one line solutions because they're pretty. But the one line solution might not always be the best. Sometimes the best solution might be several lines. So it's just that's an interesting. We got to break that mental block as well, right? Well, so Vaxerel, we're actually going to look at several different ways to do this. Yeah, so there's more that like with any coding challenge, there's always more than one way to do it, right? And so we're going to look at several. All right, let results. So we declare the result first, and then we set up our for loop. So for, and I know it's written out right here, right? But I'm not going to copy and paste it. It's good to it's good to type these things out and get that muscle memory. So let text length -1. So essentially we just set up our for loop like usual. So we're looping through greater than or equals 0. And we're looping through, in this case, we're looping through in reverse, right? Instead of doing an I++, we're doing an I minus and looping through in reverse and stopping when we reach 0. So results plus equals text I. Yeah. So we're looping through in reverse, and we're looping through in reverse because we're starting at the end of the word and taking that letter and adding it to the start of our resulting string, right? Starting to get weird. Yeah. And Fjord says, my nested for loops might be the best solution then. Maybe. We're gonna learn how to test that, so you can do your own tests as far as what is the fastest solution. So yeah, we'll definitely get there, and we'll learn how to do those tests. So return results. All right. So this is the next way to do it. All right. And so it just reminding us for loops are used to execute a piece of code as long as a condition is met. In the solution below, we use a decrementing. So decrementing here meaning counting backwards. We use a decrementing for loop to run through the string received and append each character to another variable in reverse order. So we just did that. And now notice how we initialize the iterating variable I for the length of the string -1. And since the index begins at 0, this gives us the index of the last character in the string. We append this last carrier to our result variable, which is an empty string, so putting it first, and continue the cycle until we are past the first character of the string, whereas I is no longer greater than or equal to 0. So I think most of us know how loops work, but we may not always use decrementing loops, and so that's just an interesting approach. Now, again, looking at ES6, we can get a little fancier, and instead we could supplement this by using a for of loop instead. So for of is used to execute a certain piece of code for each distinct item of an iterable object. So if there's something we can iterate over, we can use for of on it. Southpaw says, "Do you keep your VODs up?" Yes, I do. Yeah, they're up. They're on Twitch for 60 days, and then after that, they are definitely on YouTube. So !YouTube if you want to link to my YouTube channel where you'll find all of my older stuff that's not on Twitch anymore. So again, !YouTube if you want my YouTube as well. The big four for brute force: loops, variables, conditionals, and functions. Yeah. Yeah, the manual for loop is a good to teach to beginners because they can apply it. Yeah, it can be applied in multiple ways, right? Yep. But let's go ahead and do the for of as well. All right, so with for of, it's very similar, except instead of having to, set up our I and do the decrement and all that, we can just say for let car of text. So essentially, because our string is an iterable object, it has items that it has characters that we can iterate over. We can just say for let car of text and then say results equals car plus result. So again, this works because we are taking the result and putting each character in the front of it, right? So as we loop through, we take each character and we append it to the front of the existing string. So that still works just like this decrementing for loop does. We should pull what would be the fastest. Yeah, how's it going backwards? Well, it's because of this line right here. Each character that we're looping through, each character that we're looping through, we take it off the end of the string and we append it to the start of the result. So, for example, on the first loop, if I pass in the word algorithm, I start at A, the letter A in the word algorithm. I start at A, and we start with an empty result. And so my first letter in here is A. Okay. The next letter in my input string is L, right? And so we take that L and we say car plus result. Okay. So what does that mean? That means L, which is the car, plus A, which is the result. And so what I end up with is result now equals LA. And then my next letter is G. I take G, it's my car, I put it in front of the result. So that becomes G plus LA. And once I do that, I have GLA. So you can see where this is going, right? Yeah, got it. Awesome. Yeah, add it to your utility belt. Yep, 100%. So yeah, we're going to solve the problem in all four ways. We're going to make sure that they all work. Yeah, it does look weird at first, right? No worries, full moon. Okay, so that's a few different ways we could do it. The next way is the recursive way. So recursion is a programming technique in which the intention is to reduce the problem into smaller instances of the same problem until it is completely solved. In the solution below, we'll write a function that does exactly so by calling itself repeatedly. So we probably don't have a ton of experience with recursion, but essentially, yeah, that's what it does. We can have a function that performs an operation and then calls itself again and performs the same operation again on potentially a smaller chunk of data, right? So it keeps calling itself until all the operations are complete. No worries, Frazee. Thanks for tuning in. Recursion, yeah, recursion can get weird. Yep. Okay, so let's see how we do that. All right, within this function, we can make use of the substring method in JavaScript to return a portion of the text receives. It expects two parameters, one specifying the starting index and the other specifying the number of characters afterwards, which is optional. All right, so let's see what we're doing here. So we're essentially just saying if text is blank, return empty. So essentially what we're doing here is saying, all right, if there's no text, then stop the function and return an empty string. All right. If it's not, then we're going to have it call itself substring 1 plus text 0. Okay, so essentially here, our function is going to keep calling itself, and oh, that's the word I was trying to think of, and until it reaches the terminal case. So in this case, yeah, this first if statement here, this is our terminal case. This is going to end it so it doesn't keep going forever, right? This is what's going to tell when this function is allowed to stop, when it's allowed to stop calling itself. So we first run a check to see if we have an empty string. This is known as the terminal case, the case that ends the recursion. Without it, the process would continue in an endless loop. It would keep calling itself until I don't know, the browser ran out of memory or something. That's definitely not what we want. When the text is empty, we return an empty string and the function terminates. When it's not, we call the reverse string function again, and a new string created by removing the first character of the text is passed in. So I think so I could try to verbally explain this, but they actually explain it using a table, which might be more helpful. So if I call this function on the word code, the first time I do it, I'm passing in the word code to start the function, right? We first call it passing in the word code. So what gets returned is C. And then the next time it runs, it's being called on text substring 1, which just calls it on ode. And then in the next run, the O is stripped out and it's just called on DE. And then finally E, and then finally an empty string. So each time we're calling it, each time it calls itself, it's called on a substring and the first letter is stripped out. So we continually remove and return the first character on each call and re-execute the function on what is left. And in the end, we've successfully returned every character in the string, and joining them together from the last call from the last call upwards gives us the string in reverse order, which is edoc. So the last string is empty. Yeah. So the way this executes itself, each time we're stripping out each letter, calling it on subsequently smaller and smaller versions of the word until we return to an empty string. And so then in the end, what is returned is edoc. Yeah. Okay. So that's the recursive way. This content is not available. And then the last way we're going to look at is using reduce. The last way we're going to look at is using reduce, and then we're going to see which one is best. Well, first we're going to run test cases to make sure that they all work, and then we're going to see which one is fastest. What was the question? I do in fact look like this content is not available right now. All right. Oop, cancel. No, I don't want to paste anything in the terminal. All right, using reduce. So the last one, reduce, is one we've probably seen, but you may not have made a ton of use of. Reduce method is used to execute a function on every member of an array until it results in a single output value. It receives the function to be executed and the initial value of the accumulator as arguments. The accumulator serves as a holder for the value returned in the last execution of the callback. Wow. Okay. Whew. So what is that actually doing? So what it's doing is it takes an array and it does something for every member of an array. So it just does a thing. So it goes through each member of an array and it does something, and you tell it what it's supposed to do, right? And then in the end, a single value is the result. You get a single output. So you tell the function to be executed on each item in the array, and you also pass in the initial value of the accumulator as arguments. So as we go through each item in the array and execute this function, the cumulative result is stored in what we call an accumulator. And then each, subsequent execution is then added to that accumulator. So we'll see how this works here in a second. Okay. So function reverse string. Oh, why am I typing this out? I need to copy and paste. And we'll take a break here in a second. I just want to get through this last one. We'll take a break, and then when we come back, we'll do the tests. And y'all, during the break, y'all can debate which one is going to work the best. All right, so how this one's going to work with reduce is just return text split, and then so we're first thing we're doing is we're using split to convert this into an array, right? And then we pass it into our reduce. And again, reduce takes two arguments, right? It takes the accumulator, and we can call that whatever we want. And it also takes what we're iterating through, in which case is just the characters in our string. And so what do we want to do each time we iterate through one of those characters? Well, we want to take that character and add it to the start of our accumulator. And we want the initial value of our accumulator to be an empty string. So this looks very similar to the for of loop, right? Taking the character and adding it to the start of the result. In this case, that's very similar to what we're doing here. It's just a nice one, it's just a smooth one-liner solution, right? Yeah, and TJ says, I need to practice reduce more outside of math functions. It never comes to mind. Yeah, it's just not necessarily one we think of. But it could be really useful. We can do multiple functions in here, multiple operations, inside of reduce itself, and just have it automatically just iterate through everything in our array. Lots of guesses about which one's going to be best. Well, we'll see. All right, so in the solution above, we split the text received into an array of characters, and we call reduce on the array. Starts with an empty string, accumulates each character in reverse until it's gone through all the characters in the array. At this point, it returns the completely reversed string. Yep. And so again, we could also do this using ES6 spread operator. So the same as we did before. I'll just go ahead and replace this with spread. Oops, wrong bracket. Text, and that'll do the same thing. Okay, so when we come back, we're going to test with Jest to make sure, essentially do like the Code Wars test, right? Make sure that each of these returns the correct result and is what we expect, gives us the output that we want. So this is not speed testing, we're just testing for correctness. And then the next thing we'll do is we'll test for speed. Yeah, I can do. I'll do a poll for this. So I'll start the break, and I'll set up a poll as well. Yeah, in this case, exactly. So in the end, once we finish looping through this string, the end result is all stored inside of our accumulator and then returned. Yeah. Okay. So let me. I'll get the timer going, so you don't have to watch me set up the poll. And then I'll run the poll as well, so y'all can guess. So again, remember we have four. We wrote out a few more than that, but we have four options here: chaining built-in methods, using a for loop, recursion, and reduce. So I'll set up a poll for that during the break. 5-minute timer. And also keep an eye out for the poll, which will appear. So, how you can vote in the poll is you'll see it at the top of your chat window, and you can pick which option you would like. Give me a couple minutes to get that set up. All right, I'll see you back here in 5, and we can finally figure out which is the best way to reverse a string. All right, I've banned them. Don't worry. I got it. I need to edit the poll. I made it too short. Hang on. Okay, the poll is now up. You'll see it at the top of your chat window. No, no, the poll is back up now, so you can vote again. I made it too short accidentally the first time, so it's now a 5-minute poll. So you've got plenty of time. Hey, CM Griffin, thank you for the raid. Wow, again, thank you so much. We've got about a minute left in the break, but then we're going to get back to it. Welcome, welcome. Hi, folks. Yes, feel free. If, all the new folks, welcome Raiders, by the way. All the new folks, feel free to vote in the poll that we've got going on about the fastest way to reverse a string. We just did a bunch of um, potential ways to do it. We're just guessing which one is the fastest now. All right, I'm gonna go ahead and stop the timer here. Hello. Again, thank you for the raid, CM Griffin. I really appreciate it. Thank you so much. Yeah, and check out the link that Full Moon there shared as far as what we are looking at today. We are doing a basic data structures and algorithms course for funsies. Where is it? Where did it go? There it is. Um, and we're just practicing some algorithms and different ways to solve them, right? Thank you for stopping in, everybody. Good to have you all here. Okay, so let's see. All right, now before the break, we were just talking about we've done all these different implementations, right? And so, how can we test them? How can we test them? Um, Testing correctness with jest. So, in order to run the test on each implementation we found above, we can run the following command in our terminal. Really, all we need to do is just say run test reverse string. But what I'm going to do before that is I'm going to do just a little bit of cleanup here. I want to have, just for conciseness sake, I want to have one function for each method, right? So I'm going to get rid of the non-spread method here. I'm just going to get rid of that one. Um, oh, thank you for the sub 21. I really appreciate it. Using that Prime sub too. Spend those Bezos bucks. Thank you. Robert says, testing? You mean shipping to prod and waiting for support tickets, right? Oh man, you better believe it, Robert. At one of my former employers, we didn't have a dev environment. Yeah, literally one did not exist. All changes were made in prod. And it was the Wild West, let me tell you what. Luckily, my current employer has literally like 5 dev environments. I think we only use 4 of them, but yeah, 5 dev environments, and it's luxurious. It's wonderful. I love it. Oh, thank you, 21. CM Griffin says my best testers are my users. I believe that's called the screen test. Yes, yeah. All right, so we're gonna keep one for that. I'm gonna keep one option for the for loop. Now you don't have to do this, but I'm just cleaning things up a little bit. So I'm gonna keep the let care of text. Do that, and I'm going to what did I do here? Oh, accidentally pasted that twice. Get rid of that. Okay, so now we have one example of each type. Okay. All right, and so now in order to run this test, I don't remember if I need to comment out each one and do them individually. I honestly don't remember, but so we're just going to YOLO it and try it. All right, npm run test reverse string. I am going to copy this, and let's just see what happens. Might air it out. Who knows? Okay. Did not pass. But here you can see the results, right? 3 failed, 1 passed. Okay. Everyone has a test environment. Some are lucky it isn't prod. It's a thing. Yeah. All right, let's do one at a time. I'm going to comment these other ones out. Oh, I think, you know what? I didn't save it. That's why. I always do that. I need a channel points reward that like throws up a sound alert that says you forgot to save. I really need that. All right, let's try again. Okay. We'll get it. Yay, we passed. Go us. Yeah, I need or a chat command. I need a chat command for you forgot to. I just need something that like puts a flashing banner in the middle of the screen like that says you forgot to save, because I do that on every single stream. So yes, all of our implementations passed, and we can see the test cases here. So we tested to see if it's a function, number one, versus a string of text, versus a string containing numbers, and versus a string containing mixed case characters. So how do I know what it's going to test? How do I control that? And you get, how do I, so I'm going to let you all answer. How do I control which test cases are passed? Or which things are tested? Yeah, it's in test.js. Exactly. So we have this test file that it's pulling these test cases out of. It's not, it doesn't know what we want to test. We have to tell it. So in this case, we just go to test.js and we can write our own test cases here and just say, hey, look in here to get the test cases. Okay. So in this case, we're testing to see if it's a function, and what we do is we say, all right, we want the type of reverse string to equal function. And then for the second one, we're passing in AEIOU and then telling it what we want the result to be. Now it's behind my head. You can't see that. All right. So we tell it what we're passing in, we tell it the input, and we tell it the output. And then for the next one, again, to see if it can reverse a string containing numbers, input and output. And then for the last one, we have mixed case characters. We tell it the input and we tell it the output. So you can, if you want to build your own test cases, you can copy and paste this and, this format and use your own. And this should look somewhat familiar because Code Wars uses a different tool, right? They uses Mocha. But this should look similar to what you've seen in Code Wars when you've been doing those. All right, so I see a few people getting errors. So let's look at each of these individually and make sure that we can do them all individually. So, all right, save. We'll do the first one. If you're getting errors, you might try them individually, but make sure that you have the export at the end. So make sure you didn't accidentally comment out your export. All right, we'll do the first one. Okay. Again, we passed. Go us. So now we'll comment this one out and we'll do, whoops, about dropped my mouse there. We'll comment this one out and we'll do the next one and save. And try it again. Okay. And again, we got it. So if you're getting an error, you might have a typo somewhere. What you could do is you can always look in the, so that we have this other file here called solutions. And so you could always double check and make sure that, maybe you have a typo somewhere. All right, let's do the next one. So reverse string. And again, we're not testing speed here. We're just making sure that each of these, meets the criteria, right? So can it do the task? Yep, again, we passed there. Hey, you got it working, Louise. Good job. Okay. And last one. Testing, testing. Yay. Okay, so they all passed the test, right? Robert Tables. I love this so thorough. Good. Yeah. Yeah. I mean, that's what the goal here is, to kind of, be thorough, make sure that truly all of these methods actually live up to, our expectations of this algorithm, that they do all the things they're supposed to do. Because if any of them didn't, and we tried to compare them on speed, it wouldn't be a good comparison, right? We wouldn't be comparing valid objects together. So we want to make sure that they all meet the criteria, and then we'll compare them for speed. So Zena, you were having trouble, couldn't use arrow functions. Yeah, let's see, is that specified in the? It's interesting. So the test case actually has an arrow function. So I don't know enough about these. That might be a good thing to Google to see, like, how can I use, arrow functions with this to format them properly. Yeah, it's we need to have the appropriate rigor, right, in order to actually speed test these appropriately. Yeah. And actually, I'm gonna make there we go. That shows a little bit more on the screen. Sorry, it's kind of hiding half of this. Um, make this a little bigger. There, that should be better. Okay. All right. So we've essentially asserted that all of these can accomplish the goal and that they meet all the test cases. Oh, Robert Tables, thank you for the sub. I really appreciate it. Thank you. I hope you're having a good day. Um, oh, you got it to work, Tucker Tech. Nice. Good job. All right, so every implementation passed all the tests. So let's speed test, baby. The moment y'all been waiting for. So we're gonna do that. I'm gonna show you how to set these up inside of jsbench.me. So if you haven't already, go ahead and go to jsbench.me, and I'll share this link already. Boulangerie, make sure that you install. Did you do your npm install? And install. Make sure you've installed the dependencies first. So you got to be in. So when you install, make sure you're in the root folder for the project. So navigate to your root folder, do npm install, make sure everything installs, and then after that, it should work. Yeah. Okay, so I'm going to try to see. That's really hard to see. I'm going to try switching to light mode here. So hide your eyes. Ah, it's so light. Um, and maybe make this, see if I can make, no. All right, hopefully y'all can see that decently well. Winners get to ban the users. All right, so we can see here on JS Bench, it's allowing us to enter a few test cases, and we're going to enter each of these different implementations as a test case. And in the first thing we need to do though is in our setup JS. Essentially, we need to set up our initial variable that we're going to be passing into each of these, and that can be really whatever we want. Let's see, what are they doing in? I want to see what they're doing in the. Yeah, so all the screenshots are broken. We don't even know what they used as their variable they passed in. Everything, none of this stuff here in the testing section actually works. So we're gonna make our own test with blackjack and stuff. That's okay. All right, so I'm gonna go ahead and just declare a variable here. I'm just gonna say let text equals algorithms. Yay. All right, so I declare that variable here, and then down in the test case section, I can paste in each of my implementations. The light, it burns. Yeah. All right, so I'm going to grab each of these and paste them in as test cases. So we can just copy paste them in like that. And the next one, grab that, paste that in. And the next one. Now, it only, by default, it only shows you room for 2 test cases. You can add another one though by clicking on the plus button down here at the bottom. So I can add another one. Get rid of that extra white space there. And then the last one. Adding one more test case and pasting that in just like that. So now we've got all 4. And so what I should be able to do is just run this. And what it's going to do is it's going to essentially run a bunch of tests against each of these implementations and kind of get an average for how long it takes every single time. I think it does it like 60 it runs it in quick succession like 60 times or something like that. I don't know how many times specifically. And then it gets an average time to completion, and that's what it will display. And then once it goes through all of them, it will show you which one was fastest and by how much. It'll show you the splits between each one. So before we run this, let me look and see what the survey says as far as what you all thought the fastest one would be. So let me look at the poll, view results. View results. Oh, okay. All right. All right. So you all think that the fastest way to do it is going to be the for loop. That was the consensus. Okay. All right. And Rascal says there's some smart algorithm for how many iterations it does until it gets a stable result or a maximum number of allowed iterations. Okay. So it's actually smart enough to kind of be like, nope, this is too statistically variant. I need to keep going. Nice. All right. So y'all think for loop is fastest. Let's see if that's true. All right. Let's run. And all you need to do to run it is just click run. And we can see it's running multiple samples. And it will do this for each one. All right. And it finishes each one and goes to the next one. And once it's finished, it'll tell us which one is best. All right, which one won? Oh! Haha! Reduce. Reduce. Yup. Yeah, but let's look at the others. Let's see how they fared. Let's see how they fared. So, oh, but we've got a tie. Interesting. Okay. What does it say? These three are fastest. That's weird. That's not the result I got before. They're all very close. Yeah. But this isn't the result I got earlier today, which is really interesting. But let's piece this out and we'll see which one has the most operations per second. Which one has the most operations per second? So this one's 11717. This one says 1179, 1176, 1177. Okay, so it looks like actually the for loop did come in. The for loop had the most operations per second. Yeah, it happens when they're very close. Yeah. Now this I mean it did work. It was giving me the expected results. I wonder if I try a longer string. But anyway, it does look like for loop won. So let's see if let's see if that's what the text expected. Okay, so with JSPerf, they found that the reduce method was the fastest, but for loop is close, only 6% slower, so a very insignificant percentage slower. So reduce fastest with for loop second fastest. But it's a pretty close race, right? And so that's basically what we saw here. It was insignificant, the difference between them. The slowest of them all is the method of chaining, split, reduce. Our favorite one is the slowest with chaining, split, reduce, and join. Darn. That was always the go-to. Oh yeah, and that's true, Rascal. I didn't think about that. So what Rascal's mentioned is this article was written a year ago, and so there may have been optimizations since then. But yeah, JSPerf actually ran your code on different browsers, and this tool doesn't do that. And JSPerf is broken. Yeah, it's yeah. Well, it's I don't know why. I don't know if it's actually broken, but it's not available anymore for use. So yeah. And there's also value in which one is the most readable. Yeah. I think also too, LeetCode may do some speed testing. You may be able to do some speed testing in LeetCode as well. Okay, so gcomer says you need to put the function bodies in the setup section. Okay, maybe I'm doing it wrong. Let's try that. We got time. Uh, all right, so let's do this. Take these out. I've literally never used this tool before. So I looked at some examples and it seemed that they were putting like they were declaring the starting array here and then, putting the functions in each of the test cases, but maybe I'm wrong. So let's do that. We'll put this in here and then I'll say let text equals algorithms. And then we'll do a different one down here that's much longer. I'll just do a bunch of random characters. There. Oh, am I missing a curly brace? I am. Good catch. Okay, and then we'll just do two test cases for starters. I'll get rid of these two. Okay. But this is not necessarily allowing us to compare these these different implementations together, right? It's not it's not showing us how we can compare them. It's just allowing us to test one at a time. Oh, okay. So call it on. I see what you're saying. So do this and do this and call it on the word algorithms. Algorithms. Oops, that's wrong. There. Okay, we'll do that. Yeah, that's the thing. I don't think this is really doing what I want. Because I want to compare multiple different functions together, right? So, but I mean, I appreciate that actually that you're telling us how to use the tool. Okay, so but I would be curious to see if this one actually takes more time than this one. Yeah, so that's it's a longer string, it's slower. Yeah, absolutely. Exactly, Tucker Tech. Yeah, what I wanted to do was run these against each other and compare the speed at which they could execute. I thought this was going to do that for me, but apparently not. Um, yeah, because the bigger argument should take longer. Oh, Commer's got it. Okay, so okay, let's do that. We'll declare each of them with a different name in the setup. I think I see what you're. I think I'm picking up what you're putting down there. All right, we'll get it. We'll get it. All right, so reverse string. Let's do this. Let's call this RS, and then with what is this one? This is wait. I want to put them in order. RS reduce. Do this. RS reduce, and then the next one is going to be RS. And then what was this one? This was 4, RS4. Okay. And then this one, next one will be RS, what do I call this? Recursion. Recursion. And then the last one, RS reduce. Come on, scroll down. Thank you. Okay. There we go. Oh, yep, you're right. So this one is RS chain. The first one is RS chain. Yep. Thank you. Yeah, I got it. Thank you, though. Yep. Good catch, everybody. I didn't catch that one because these one look similar. So yeah, got them in the wrong order. Okay, let's try this now. So for each test case, I'm going to call each of these on the same word. So we'll just pass in algorithms to each of these, or engagement. Yeah, it's all engagement, right? No, I do appreciate those of you who have used this tool before and know how to use it. I appreciate that you're telling me how to use it because I literally just like found this tool, 2 hours ago or something. So I do appreciate it. All right, let's call it on, I don't know, a random string of characters that I'm going to pass into each one, just to make sure it works. All right, copy each one of these. So I need to make this a little bigger. It's hard for me to, there we go. Okay. RS chain, the next one is RS4. And then add 2 more test cases. And what do I call this one? RS recursion. Yep, exactly. Another good catch. More engagement. All right, RS recursion and RS reduce is the last one. Okay. Oops. RS reduce. All right. Okay, let's give it a try. And again. Okay, make sure I got all my curly braces here. Let's go. All right, done with that one. No errors yet. That's good. Oop. Okay. Ah, I fixed the function name here, but I didn't fix it in the body of the function. So let's try again. There. This is it, folks. The suspense. Yeah, I'll abstract out that into a variable. I just want to make sure I was doing it right first, but yeah, we can, once we know that this works, we can abstract the text out into a variable. Okay, which was fastest? Ah, the for loop. For loop was fastest this time. So the poll still stands that the for loop was the fastest again. With, let's see, but reduce was next. So it was basically very similar to what the text said. For loop and reduce were still in hot competition. With chaining, and so yeah, like they said, chaining was slowest. I think they said chaining was slowest, and then what was the other one? Recursion was also fairly slow. Rigged. Okay, so now that we know how to do this, we can actually abstract this out into a variable and just say, text, right? We could just do this instead. We could say, let text equal, and then whatever we want. So, all right. So if you wanted to, you could pass in all of the, not like that. All right. You could pass in all the test cases if you wanted to. You could make it 1,000,000, you could make something 1,000 characters long and pass that in and really try it at scale if you wanted to. Yeah, we can. Okay, all right. We can do a long one. All right, let's do, what is it, lorem ipsum generator? Let's do 10 paragraphs of lorem ipsum. All right, and I copy that. Okay. And I'm going to move my my text variable down to the bottom of this. And drop that in. You think the 10 paragraphs is going to crash it? We'll see. I don't know. I don't think it will. All right, close that string. Okay, whoop, come on now. Okay, let's see if we get anything different. Make sure I fixed all these properly. Yep, okay. Text. I don't know if it's actually gonna, I might need to make this into a one-liner here. I don't know that it's recognizing that string. We'll see. It might error out. But we're just playing around. It's okay if it does. All right, let's see. I didn't like that. Okay. Okay, we can try a shorter one. We'll just try one paragraph for starters. Here, I'm going to do this instead. We'll do, okay, set up string, and then do one paragraph, regenerate, take that, and drop it in. Yeah, okay, that's recognizing it as a string. Good. For some reason, it didn't like it when I tried to put independent quotes on either side. Okay, so I'm going to do another paragraph just for funsies. Choo, choo, choo. Okay, good. We're still recognizing as a string. Good. Here, let's try it again. There we go. And Comer suggests using backticks for a multi-line string or dot repeat. Good suggestion. Aha, for loop wins again. It's not that bad. Now, it wasn't really much slower. For loop still wins. What comes in second? Ooh, it's close. But again, reduce is second. Yeah, I didn't like the line breaks the first time. Yep. Yep. So again, same results as before. For loop still wins. Yeah, it's wild. It's just fun to play with this stuff, right? We can make it longer. I just pasted in a bunch more. I'm never chaining method again. For loops forever. Just keep pasting. Yeah, I mean, it did go, I mean, relatively, it went pretty fast, right? So go, 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 go. Okay. I pasted in a few more just for funsies. All right, one more. Let's do it. We're going to do one more. Okay. Oh, it's slower now. For loop is visibly faster. For loop was visibly faster completing those tests. Oh no, recursion's not going to work. The old Code Wars standard, too many calls. Sorry, recursion. I figured that might happen. Okay, but again, same results as before. We're seeing a pattern here. For loop wins, followed by reduce, followed by chain. And I thought this might happen when we get long enough, but recursion couldn't hack it. Yeah. So and also to be clear, for this I was using for of in this particular loop. I used for of. Um, Yeah, and Tucker, that's a that could be an answer. You could say like, well, why didn't you use recursion? Well, I was worried about filling up the call stack. Yeah, there you go. So at this point, this is more of just kind of a fun little exercise, right? This is more of just a fun little exercise. It's not really life or death for us at this point. I think Leon's going to talk more about how we can do this kind of testing tomorrow. I just kind of wanted to show, like, how you can kind of get these types of results. And it's interesting, that what we're seeing is not necessarily what the text is seeing, but it could rely on a lot of different variables, right? It can rely on a lot of different factors. They've said that before. Performance can have a lot of different things that go into it. So it's kind of interesting. And DevD says for them, for of was slower than the usual for loop. So that could be another thing that you could double check that too. You could do a test case against for of versus regular for loop. Yeah. So this can just be a fun thing to mess around with for now and get the feel for, what's faster, what's faster, what's slower. Does it, can you do multiple experiments and get the same result? Can you try different data types and get the same result? What happens? I think I missed a question, sorry. Talk about Big O. So we haven't really talked about Big O in class yet. I think Leon's going to talk about that tomorrow. So I'm going to let him talk about that. I don't think they even really talk about it in the, yeah, they don't talk about it at all in this chapter. So we're not going to get ahead of ourselves. Let's just let Leon explain it tomorrow. Um, but we're just kind of getting a feel for what our options are, right? What are the different algorithms that we can use to solve this problem, and how do we test them? Leibniz says modern computer architecture is not designed for recursion, but favors imperative loops. Ah, okay. And TJ Khan kept all the initial functions. I assume you mean the ones without the spread operator. Is that right? Spreads were, okay, I see what you mean. Spreads were slightly slower. So using the spread operator, ES6 spread operator, was slightly slower than split. That's a lot of S's. Slightly slower than split in both cases. For of was 30% slower. Wow, than just a regular for loop. So using some of those ES6 notations actually slowed things down. That's wild. Yeah, and Flowstone mentions, I think Brascal mentioned before, the article is from over a year ago. So implementations under the hood. This is from like several years. Yeah, well, this was this course was deprecated in January of 2020. So if y'all are, have lost track of time, that was actually 2 years ago, more than 2 years ago, almost three, which is friggin' wild. So yeah, a lot of things could have changed since the article was written, right? And Rassel, the angel that they are, have set up have set it up for us in JS Bench. So if you couldn't get it working at all, feel free to use Rascal's example as well. Thank you, Rascal. All right, and thank you to everybody that helped me get that working in the first place and working properly. So thank you, thank you. I'm going to be using this, probably using this in the future, unless Leon gives us a better option. But because it's just fun, right? It's fun to test these against each other. It's fun to have little races and see which works best, and tweak things, and tweak sub cases against each other and see which one goes fastest. Zena says, I really like spread syntax. Yeah, that's the thing, right? Is sometimes as you get more and more, sometimes as you get more and more abstract and keep adding layers on top of what's actually happening, you can sacrifice performance, right? The more you abstract, the more layers you have to dig down to actually execute the thing. So I don't know if that's what's happening here, but that's a very interesting finding. I appreciate that folks found that. Okay, convenience at a price. Yeah, absolutely. Bangers with band. Awesome first day here. That's rad. Yeah. Tucker says, I always forget what the dots are for in spread operators. So what the dots are just, it's basically just notation to say like, we are taking this thing, whether it's, so we're essentially in this case, we're taking this variable and we're pulling it apart. It's just, that's just what that notation is for. It's just, we're taking this variable and pulling it apart. Roscoe said, it's the scientific method. Come up with a hypothesis, test it, and see if it matches up with the prediction. That's all we did here. Yeah. Oh, the change we had to do to make big paragraphs work is just no line breaks. So it doesn't like, if we wanted to use line breaks, we would have had to use backticks. But if you want to just use regular quotes, just make sure it's, you don't have any line breaks in there and it's all one line technically. No carriage returns. Yeah. So feel free to, feel free to keep, you know, slicing and dicing and doing different tests on this. But now you know how to do it, right? Now we know how to do it. Now I know how to do it, and so we can do this for ourselves now throughout the rest of the course. And speaking of which, so at the end of this, um, they give us some further reading. If you want to learn, if you want to read more about each of these methods that were used here, they give us further reading. I haven't tested to see if these links actually work. At the very least, when you click them, you'll be taken to a web archive link. So if you, let's see, where's this taking us? It's taking to the MDN, right? So you know how to go to the MDN and look stuff up. And then there's also a YouTube video about recursion. So if you're struggling with that recursion problem, that recursion implementation, maybe give this video a watch. Remember that when you click on these links, you'll want to take off the web.archive prefix. So, for example, I don't even know if this one's going to work. We'll see if it even takes me there. Yeah. So it does work, but I would suggest removing the web.archive prefix on there and just going to YouTube and watching it there. I want to fork this now so I can keep it in my GitHub. Yeah, go ahead, do it. Oh, backticks instead of, yeah, I believe backticks will let you do multi-line. Yep. Yeah, so like the ticks you would use for a template literal. Same ones. Okay, so we made it through the introduction, we made it through the setup, and we had a lot of fun with the first algorithm. However, there are many others. But we're not going to do those together tonight because it's time to wrap up the stream. Um, However, I think the goal is to not have the entire course complete by tomorrow. The idea is that you've had a decent introduction, and I think we've done that. I think we've learned some basic terminology. We've learned how to define data structures and how to define algorithms. And we've learned what the components are to an algorithm, right? And yeah, and how to do basic setup on how we can build test cases and test our code ourselves and benchmark our code ourselves. So I think this turned out pretty good. All right, so I will see you all tomorrow in class for another introduction to data structures and algorithms. But you all have a leg up now, and you know what these words mean. So I'm glad it helps you feel less alone. That's awesome, Full Moon. And thank you for everybody here for all the help on getting everything working and all catching all my mistakes. So I always appreciate that. And again, the best way to learn is to teach, right? So I do appreciate all the help. No cat with a mustache yet, Mavi. I'll let you know. I'm glad it was fun. All right. All right, let's find somebody to raid so we can spread the love to somebody else. And yeah, let's keep that chain going, as CM Griffin said. Yep. All right. Let's see who's online this evening. Okay, we got several choices. Time Enjoyed, who's doing art. Also, feel free to suggest somebody if you have somebody you'd like me to raid. I do prefer folks that are in the software game development space, but it doesn't necessarily have to be. So we've got Time Enjoyed doing art. We've got Midnight Simon, Team Vash, they're game devs. Ending with Ali, doing software and game development, and Nikwan Data Sci. I think we just. Oh man, but they're doing algorithms. I was like, I think we just rated Midnight Simon a couple streams ago. But okay, we got a lot of folks saying Midnight. All right, I'm fine with that. If y'all want to raid Midnight, we'll raid Midnight. That's all good with me. So they're doing okay. They're doing algorithms, and it looks like they are doing a co-stream with somebody else. Yeah. So that should be fun. I wonder who they're coding with. Maybe that's somebody else you could follow too. All right, I'm gonna go ahead and start the raid. We'll raid Midnight, and okay. Yeah, and go ahead and do some more algorithms with Midnight Simon and their friend. All right, raid is starting. I will see you all back here again, maybe on Sunday. We'll see. Keep an eye on my Twitter. Keep an eye on my Twitter for any schedule changes. Exclamation point Twitter if you want a link to my Twitter handle. All right, I'll see you all again soon. Bye bye.